Okay, we're still in section 1.2 and we've come to the power functions section. So what is a power function? Well, the book defines power function as f of x is equal to x to the a. Alright, so we know we know what the graph of a power function looks like when a is a positive integer. In other words, when it's not negative and when it's not a decimal or a fraction. So what happens if a is involved in a fraction? What happens if the exponent is a fraction? And what happens if the exponent is negative? You've actually learned all this stuff already in college algebra and in regular algebra. At least you should have. But we're going to review really quick exactly what this means. So you know the graph of a square root. Okay, it looks like, really quick, square root looks like that. Alright, and then cube root looks it's the same thing, but it goes on both sides. Alright, its domain is all real numbers, the cubed root. Whereas the square root function, the domain is from 0 to infinity. And that actually happens with all even roots. With all odd roots, it's all real numbers. So, why am I talking about root functions? Well, we get a root function when the exponent of a power function is a fraction like this. So x to the 1 over a is the same as the a root of x. So x to the 1/2 is the same as saying the square root of x. X to the 1/3 is the same as saying the cube root of x, and so on. Okay, so when we have x to the 1/2, as in here, our graph is going to look like the square root of x. When we have x to the 1/3, right here, we're going to have a graph that looks like the cube root of x. Actually, it should be up here, but I drew it so you could distinguish. What if the exponent is negative? When the exponent is negative, we get what is called the reciprocal function. Okay, and we can rewrite, I'm going to do a different color. We can rewrite, for example, x to the negative 1 as 1 over x. X to the negative 2 is also the same as 1 over x squared, and x to the negative 3 is the same as 1 over x cubed. And look, x is not defined when it is equal to 0. So when we draw the graph of x to the negative exponent, we're going to have something like this, and then the reciprocal function. Okay, it has a vertical asymptote at 0, at x is equal to 0, and it does not cross it. It gets infinitely close to it, just does not cross it. So I'm going to now show you all of the formal graphs in my grapher application. Another interesting thing you should notice is that I have graphed right here x squared, x to the 4th, and x to the 6th, even powers of x. And look at where they all intersect at. They all, besides 0, they all intersect at 1, 1, and negative 1, 1. Why? Well, 1 to the anything is 1, right? So they're always going to, even powered functions will always intersect at 1, 1, and negative 1. So let me add x to the 3rd, x to the 5th, and x to the 7th, and get rid of the even powers. Here's the odd powers. Alright, let me bring it up here. Here's the odd powers graph. They also intersect at the same points. So you have x cubed intersects everything else at 1, 1 and negative 1, 1, right? Why? Because 1 cubed is 1 and negative 1 cubed is negative 1. So all odd powers will intersect each other at these points. They'll get a little plumper and a little skinnier, but as the exponent increases in odd value, but that's okay. Now let me show you in the reciprocal functions. I must said inverse. Here's x to the negative 1, x to the negative 3 and x to the negative 7th. They get infinitely close to 0, x equals 0, but they never actually touch x equals 0 or the y-axis. Let me now graph x to the 1/2, x to the 1/4, and x to the 1/6 even fraction exponents of x. And they all, too, intersect 1, 1. Same with the reciprocal functions, 1, 1 and negative 1, 1 for them. But with the even roots, they all only intersect 1, 1. They're not defined elsewhere else. Well, that was weird. Alright, now the odd fractional exponents of f of x. So this is 1 to the 1/3, or I'm sorry, x to the 1/3, x to the 1/5, and x to the 1/7. And they, just like the odd exponents of f of x, all intersect each other at 1, 1 and negative 1, negative 1. Okay? So keep all this in mind. I'm going to quickly put them up just to see what it all looks like together. It's important to know all of these graphs because it helps with quickly finding the domain, the range. Ooh, that's a real interesting picture. Wow, look at that. Functions, math is interesting, guys. Math is really interesting. It would be like, wow, this is really symmetrical except for this odd looking part. That's the x squared, x fourth, x 6 right there. That's really interesting. But anyways, so this is all the power functions, right?